Hello guys, welcome to my YouTube channel Physics Prince. My name is Deepak. I'm going to teach you all 9 subjects of physical science in detail. Are absolutely free of charges. My courses are going to help the students who are preparing for CSIR, NET, GATE, NT exam, PhD exam, SET exam, TIFR, Jest, IIT and other exams related to physical science. Okay, so this is the lecture number 3rd of atomic and molecular physics. Okay, and also guys, I would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures which are going to help you to crack the exams related to physical science. Okay guys, and also guys, I would request please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, so let's get started. So there's a question. Okay, this is the third lecture of the atomic and molecular physics. A beam of electrons, a beam of electrons, a beam of electrons enters into beam of electrons enters into a uniform magnetic field, uniform enters into uniform magnetic field of flux density of flux density 1.2 Tesla. Calculate the energy difference the energy the energy the energy difference calculate the energy difference between electrons whose spins are whose spins are whose spins are parallel and anti-parallel are parallel and anti-parallel 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 to magnetic field. Okay, so options are option number A 2.4 mu b, option B 1.2 mu b, option B 3.6 mu b, 3.6 mu b, and option D mu b. Okay, so this is the question. Okay, so question is a beam of electrons enters into a uniform magnetic field of flux density 1.2 Tesla. Okay, so beam of electron is entering in the uniform magnetic field. Okay, uniform magnetic field of flux density is given, that is 1.2 Tesla. Calculate the energy difference between electrons whose spins are parallel and anti-parallel to magnetic field. So we need to find out the energy difference. Okay, so some are parallel and some are anti-parallel to magnetic field. Okay, so very good question. Okay, so guys, this is the direction of magnetic field. Okay, and the electrons whose spin is parallel to and u1, so u1 is going to be minus mu b cos theta, right? Mu dot b means mu b cos theta or mu b cos 0 degree, right? Because these electron to magnetic field, right? 0 degree, and this value is going to be cos 0 is 1. This is mu b minus mu b, right? And similarly, this is the direction of magnetic field, and now those electrons whose spins are anti-parallel to magnetic field. Anti-parallel to magnetic field means they are at 180 degree. They are at angle 180 degree, right? 180 degree, or we can say pi. So in that case, U2 is going to be minus mu b cos 180. Cos 180 value is minus 1, so U2 value is going to be plus mu b, plus mu. Okay, plus mu, plus mu. So this is U1 and U2. So we need to find out energy difference, right? So energy difference is going to be uh, energy difference, that is delta U, which is going to be U2 minus U1, right? So this is going to be U2 value is mu b. It is going to be mu b minus mu b. U1 is minus mu b, right? So this value is going to be uh, 2 mu b, 2 mu b. Okay, and b, so this is delta U. So delta U is going to be 2 mu b, 2 into mu. So this is mu b, right? So this is going to be, this is mu b, guys. Okay, mu b. So this is going to be mu b b, mu b b minus mu b b. Okay, so this value is going to be 2 mu b b. Okay, and so from here 2 into mu b into b value is given 1.2. Okay, so this is going to be 2.4 mu b delta U equal. Okay, so this is the energy, 2.4 mu b. Okay, this is the uh, energy. Okay, this one. Okay, so this is mu b, mu b, and mu b. Okay, mu b. Okay, so this is the answer, guys. So which option is matching? Let me check. Option A is matching, guys. Option A. This one. 2.4 mu b. 2.4 mu b. Okay, guys. Next is fine structure component. Fine structure. Fine structure component. Fine structure component. Fine structure component. Okay, so in Sommerfeld model. Okay, so fine structure component we need to find. So we have in Sommerfeld model, Sommerfeld model. Sommerfeld model. Okay, so we have delta k equal to plus minus 1. Okay, and this is the selection rule, right? We know delta k equal to plus minus 1 for the fine structure. Okay, for Sommerfeld model. So this is the selection rule. Select selection rule. This is the selection rule. Okay, so this is going to be, so H alpha line is going to be like this. This is H alpha line. Okay, so it's find H alpha line. H alpha line. This is n equal to 2, and this is n equal to 1. My apologies, n equal to 3. N equal to 3. Okay, and here k is less than equal to n. This we know, right? Okay, so this is as alpha line, right? So in fine structure, it has three components. Okay, so this is going to be, this is k equal to 1, k equal to 2. This is k equal to 1, k equal to 2, and k equal to, okay, in summer field model. So this is fine structure. So this is going to be like, so selection rule is delta k plus minus 1, right? So it means this will be 3 to 2. Transition will be 3 to 2 and 2 to 1 and 1 to 2. Okay, so there would be three components. So these are three finite lines. Okay, for this H alpha line, we have three alpha lines, right? These are three fine lines. These are three fine lines. These are three fine lines. Okay, these are three fine lines for corresponding to this line, H alpha line. Okay, so this is the fine structure components. Okay, these are fine structure components. Okay, guys. And k we know, right? K is azimuthal quantum number. Azimuthal quantum number. That is k. Okay. Next is, now we'll study spectroscopic term. Okay. Spectroscopic term. Very important one. Okay. You will get question from it. So spectroscopic terms. So this is, guys, this is 2 2s plus 1, 2s plus 1 Lj. Okay, so this is the spectroscopic term, right? 2s plus 1 Lj. Okay, so, and also, guys, you know it. I'm just writing S means, for S, L equal to 0. For P means L equal to 1. D means L equal to 2, and F means L equal to 3, and so on. Okay, now for L equal to 0, these are basic things I'm telling you. For L equal to 0, for L equal to 0 and S equal to half. Example I'm giving. Okay, how to write this spectroscopic term. So for L equal to 0 and S equal to half, 2s plus 1 is going to be 2 into half plus 1, that is 2. Okay, and J value is going to be L plus S, that is 0 plus 1 by 2, that is 1 by 2. Okay, then spectroscopic term is going to be, this is 2s plus 1 Lj, right? So 2s plus 1 value is 2 for L equal to 0 and S equal to half, and J value is half, so this is going to be 2, and L is S, for L equal to 0 we have S, right? This is going to be 2s half. This is the spectroscopic term. Okay, basic thing. Now I'll give one more example. So example number 2, that is if we have S equal to half and L equal to 3. L equal to 3 means D orbital, right? L equal to 3 means D. My apologies, F. Okay, so so value of J is going to be, L plus mod of S, L plus S to L minus S, right? So this is the value. So L plus S means half, this 3 plus half, 3 plus half, mod of 3 plus half to mod of 3 minus half, right? So this J values are going to be 7 by 2 and 5 by 2, 7 by 2 and 5 by 2, right? So and 2s plus 1, 2s plus 1 multiplicity, that is multiplicity, okay? Multiplicity, that is 2s plus 1 is going to be 2 into half plus 1, this value is going to be 2, 2 will get cancelled, that is 2, okay? So spectroscopic term are going to be, that spectroscopic term are going to be, here you can see L equal to 3 means F, right? So F, 2F 7 by 2 and 2F 5 by 2. So this is going to be spectroscopic term 2F 7 by 2 and 2F 5 by 2. Okay, these are the spectroscopic terms. Okay, or we can write like this. So this is it has two values, right? So it means this is going to be like this: 2F, this is 2F 5 by 2, and this is 2F 7 by 2. These are the spectroscopic term for S equal to half and L equal to 3 means F, right? I hope you have understood it. Okay. Now this is now we'll start SS coupling. Okay. This is SS coupling, SS coupling, SS coupling. So SS. So first you know S1. S1 is going to be S1. This we know, right? I have already explained. This is H cut into S plus 1, right? And S2 is similarly H cut root S into S plus 1. Okay. This is S1, S2, and S is going to be S1 plus S2 mod S1 plus S2 to mod S1 minus S2. Okay, these are the value of S. So now as for SS coupling, so for we can take example of one. So for one electron system, for one electron atom. like hydrogen, right? So there would be no SS coupling, no SS coupling. So for one electron atom, no SS coupling. Okay. Okay. Now for two electron atom, S1 equal to half, because there is only one electron, so that's why there is no SS coupling. Okay. And S2 is going to be half for two electron system, right? So value of S is going to be uh, mod half plus half to mod half minus half, right? So value of S is going to be 0 and 1, or 1 and 0, that is 0 and 1. Okay, so this is the value of S. Okay, so now we can find out multiplicity, that is 2s plus 1. Okay, so this is going to be 2 into 0 plus 1, that is 1, and this is for 0. Okay, for 0. For 1, 2s plus 1 is going to be 2 into 1 plus 1, that is 3. So this is singlet, and this is triplet. Okay. Okay. Now for three electron system, or three electrons atom, so this is going to be S1 half, S2 half, and S3 half. Okay. So S value is going to be this one. S value is going to be mod of S1 plus 2 mod of S1 minus S2, and this is S3 half, right? And S3 equal to half, will take 2 first. Okay. So this value of S we have already found, half plus half 1, and half minus half 0, so 0 1, right? So S is going to be 0 comma 1, and S3 is going to be half. Okay. So S dash is going to be, first we will take with 0, right? 0 plus half mod 2, 0 minus half mod, and for 1, 1 plus half 2, 1 minus half mod. This value is going to be half comma comma half, mod half is half, right? Comma 3 by 2 comma half, right? So S test value is going to be this 3 by 2 and 1 by 2. So these are the values, right? These are the values. Okay, now we'll find 2s plus 1, that is for 3 by 2, it is going to be 3 by 2, 3 by 2 into, so this is 2s plus half, right? 2 into 3 by 2 plus 1, this value is going to be 4, and 2s plus 1 for half is going to be 2 into half plus 1, that is, okay. And now I'll tell you trick as well. So trick is trick is s equal to 0, 1, 2, n times, yeah, for even, right? And this is for even n, okay, for even n. And s equal to half, 3 by 2, 5 by 2, n. This is for all odd, for odd n. It is for even n and this is for odd n. Okay. So example I'll give it to you. So like for two electrons, for two electrons, s is going to be 0, 1. Okay. For even n, okay, we are talking about even n. Even n means two electrons are even n. Okay. For odd, for okay, you need to understand for even electrons means if the electron number of electrons are 2, 4, 6, 8, then s values are going to be integer 0, 1, 2, 3, so on. Okay, if electrons number of electrons are odd like 3, 5, 7, in that case s values are going to be 1 by 2, 3 by 2, 5 by 2, so on. Okay, so in that case s value is going to be 0, 0, comma 1, right, for two electrons. Similarly for three electrons, for n equal to 3 electrons, n equal to 3 electrons means that s value is going to be 1 by 2, comma 3 by 2. Okay, again for 4 electrons, for n equal to 4, this is even, right, 4 electrons, and 4 means electrons 4 means 0, 1, okay, oh sorry, 0, 1, 2, 0, 1, comma 2. For n equal to 5 electrons, if there are 5 are odd electrons, right? So by the trick, s value is going to be 1 by 2, comma 3 by 2, comma 5 by 2. Okay, so this is how we can directly find if the SS coupling. Okay, if we have uh, s equal to, if number of electrons are even or odd. If even, then we'll use this values of s, and if odd, then we'll use this values of s. Okay. Okay, guys. So this is the trick you need to note down. Very important. Next is LL coupling. LL coupling. LL coupling. Okay, in LL coupling, and we know this value, right? L1 equal to this h cut root L into L plus 1, right? And L2 is h cut root L is angular momentum, right? Orbital angular momentum. L into L plus 1. Okay. So value of L is going to be, for this value of L is going to be mod of L1 plus L2 to mod of L1 minus L2. Okay. This is for LL coupling. Okay. So here I'll give example. For example, for one electron system, one electron system, one electron system, L equal to 0. Okay. And L equal to 0, right, for one electron system. So in that case, L is going to be L, means no LL coupling, guys. For one electron system, there is no LL coupling, no LL coupling. Okay. Now for two electron system, we'll check. for two electron system for two electron system like for example 3p1 3d1, this is two electron system, right? So for this L1 equal to 1 and S equal to half, and for this L2 equal to D means 2 and S1, okay, this is S1 and S2 equal to 1, this is half, okay. Now we'll do the coupling, so L is going to be L1 plus L2 mod 2 L1 minus L2, okay. So this value is going to be 1 plus half to 1 minus half. These values are going to be 3 by 2, 3 by 2 and 1 by 2, right? We made mistake, right? L1 is 1 and yeah. So 1, L1 is 1, L2 is 2. So 1 plus 2, 1 plus 2, 1 plus 2 to 1 minus 2. Okay, so this value is going to be 1 minus 2 means 1, 2 and 3. These are the values. And 1 means B, 2 means D and 3 means L value, right? Value of F. Okay. Next is for 3 electron system, okay? For 3 electron system. For 3 electron system, for 3 electron system. So for example 2, 3d1, 4d1. So we have 3 electrons, okay. For this we have to do LL coupling, right? So here L1 value is 1, L2 value is 2 and L3 value is also 2. For D it's 2, right? And S1 is half, S2 is half. So we don't need this S1 because we are doing LL coupling, okay. So this is so now value of L is going to be L1 plus L2 to L1 minus L2 mod, okay. So this value is going to be, and L3 equal to 2, and L3 equal to, right. So this is going to be 1 plus 2 3 and 1 minus 2 1, right. So this is 1 2 3 and L equal to 2, right. So now we'll find 1 by 1, okay. So now L1 equal to 1, L2 equal to 2 and L3 equal to 3. For L1 equal to 1 and L2 equal to 2, LL coupling, this value is going to be this one. 1 2 means 1 2 1 2, this L1 plus L2, right. 1 2 3 and 1 minus 2 is 1, right? So 1, 2, 3. Okay, so this means P, D, F. P 2, right? And for L2 equal to 2 and L3 equal, this is L3 equal, this is right, L equal to 2, L equal to 2. So this is going to be 2 to the 2 to 4 and 2 to 0, right? So 0, comma 1, comma 2, comma 4. This is S, P, D, F, G, right? So L equal to 3 and L equal to L3 equal to 3 and L equal to 2. This is going to be 5 and 1, means 1, 2, 3, 4, 5. Okay, so this is going to be P, D, F, G, H. Okay, so this is for 3 electron system. Okay. Next is important one, LS coupling. Right? You'll get question from it. Okay, LS coupling. LS coupling. LS coupling. Okay, LS coupling, important one. So LS coupling means spin orbit. Also say it is also called spin orbit interaction. Right? This is LS coupling, spin orbit interaction. Right? Okay. So the value, this total value J is denoted by L plus S. L plus S. L is orbital quantum number and S is spin quantum. Orbital angular momentum and this is spin angular momentum, right? And value of J are going to be, value of J are going to be mod of L plus S to mod of L minus S. Okay, this one. And here you need to understand, this is important point. This point is, if L is greater than S, if L is greater than S, that is L is greater, okay? If L is greater than S, then number of multiplets are going to be 2s plus 1. Which value will be less, that will be, okay, 2s plus 1. Second, if L is less than 1, if S is greater than L, if S is greater than S, then number of, which is greater, which is less, L is less, right? So number of multiplets are going to be 12 plus 1. Okay, next. So now we'll do LS coupling for one electron system first. One electron or one electron system. So we have 2p1, right, for one electron. So 2p means here value of L, is 1, 2p1, right? Implies value of L is going to be 1 and value of S is going to be 1. So J is going to be L plus S, mod of L plus S to L minus S, right? This value is going to be 1 plus half to 1 minus half mod, right? This value is going to be, this is 3 by 2 comma 1 by 2. Okay, so this is the value of J, 3 by 2 comma 1 by 2. Okay, and here you can see L is 1 and S is 1, 3 by 2, right? Okay, so for L equal to, 1 by 2, for L equal to 1 by 2, value of J, L equal to 1 and the value of J equal to 1 by 2. Number of multipliers here you can see L is less than this one. L is greater than S, right? Okay. So this I'll do later. First, we'll find spectroscopic term. Okay. So this is spectroscopic term is going to be J values are this. Okay. L value is 1 and S equal to half, right? So it means first we will find multiplicity, that is 2S plus 1. That is going to be multiplicity 2S plus 1. So that is going to be 2 into S is half, right? Half plus 1, that is 2. Okay. So spectroscopic terms are going to be J values we have, right? Spectroscopic terms for 2 electron system, for 2 electron system. Okay, like for example we have 3p2 and 2p1 3d1, right? So this is called an important one. Okay, so this is called equivalent electrons. Okay, equivalent electron. Equivalent electrons, and this is called, these electrons are called non-equivalent, non-equivalent electrons. Okay, because these are equivalent electron, because these orbital these are p orbital electron, right? And these are non-equivalent because this is p orbital electron, this is d orbital electron, right? So now there is different there are different rules for non-equivalent electron and equivalent electrons. Okay, for LS coupling. So we'll start with, for non-equivalent electron. Okay, first we will start with non-equivalent. For non-equivalent, for non-equivalent electrons, for non-equivalent electrons. Okay, we have 3p1 and 4d1. Okay, 4d1 and 4p1 and 4d1. Okay, so for this S1 equal to half and S2 equal to half, these are the electron, right? And L1 equal to, it's P means 1, and L2 equal to D means 2, right? So now we'll find this one. Is going to be mod of S1 plus S2 to mod of S1 minus S2, right? So this value is going to be, this is the 1 plus 2 to 1 minus 2, right? So means 1 plus 2 is 3 and 2 minus 1 is 1. So this is 1, 2, 3. These are the values. Okay. Okay. We have made mistake. This is actually this. These are half values, right? So this is mod of half to mod of half minus half. So these values are going to be 0, comma 1, right? And now we'll find L. Again, L values are mod of L1 plus S2 to mod of L1 minus L2. The value of L is going to be that 1 and 2, right? So mod of 1 plus 2 to mod of 1 minus 2. These values are going to be 3, comma 2, comma 1. Okay, these are, or 1, 2, 3 we can say. Okay, so these are the values. So L values are this, or I'll write 1, 2, 3, same thing. 1, comma 2, comma 3. Okay. These are L values. Okay. So now, so S values are 0, 1 and L values are 1, 2, 3. So for S equal to 0, L equal to 1, L equal to 2 and L equal to 3. These values will find, right? And these values are, and implies J values are going to be 0 plus 1. 0 plus 1, 1. This is simple, right? 1, and this J value is going to be 1. Sorry, it's 2, and J value is 3, right? So spectroscopic term is going to be, multiplicity will find for 0. For 0, multiplicity is 2s plus 1, right? 2 in plus 1, that is 1. So 1p, J value is 1. 1p 1, 1 d, L equal to 2, right? 1d 1, 1d 2, sorry, 1d 2. 1d2, and this is J equal, L equal to 3, right? So this is 1f3. These are the values for, because multiplicity is 1. Now for S equal to 1, let's calculate, right? For S equal to, for S equal to 1, L equal to 1, L equal to 2, and L equal to, this for J implies value of J are going to be 1 plus 1, 2, 1 minus 1, 0. So 1, comma 0, comma 1, comma 2. Here J values are going to be 1, 1 plus 2. For S equal to 1, right? 1 plus 2, 3, 1, 2 minus 1, 1, 2, 3. For L equal to 3, 1 minus 1 plus 2, 4, 3 plus 1, 4, 3 minus 1, 2, 2, 3 and 4. These are the J value. Then spectroscopic terms are going to be multiplicity, because S equal to 1, so multiplicity is going to be 2s plus 1, 2s plus 1, that is 2 into 1 plus 1, that is 3. Multiplicity. Okay. So here these values are going to be, now spectroscopic term is going to be 3, L equal to 1 means P 0, 1, 2. This is L equal to 2 means and 3. 3D 1 comma 2 comma 3. And for this 3 L equal to 3 means F 2 comma 3 comma 4. 2 comma 3 comma 4. Okay, so these are the values. These are the spectroscopic term. Okay, now for this is for non-equivalent electrons, right? So there is a trick I'm going to tell you for non-equivalent electrons. Okay, which is important trick, guys. I would request you understand it, learn it, okay, and practice it. Okay, so like this is simple one. You can easily solve these questions related to LS coupling. Okay, if you know this trick. Okay, so this is SS configuration. Okay, if SS is there, then this value is going to be the terms for SS. If we have SS, okay, SS electron, then the terms are spectroscopic term is going to be this one 1s and 3s. If SP, because we have this right SPDF, right? So now SS means this SP, then spectroscopic terms are going to be simple. This is 1p 3p SS, okay, SPP, okay, and then SD, and this is 1D 3D, very simple. Okay, if these are like, for example, here we can see we have 4p electron and 4d electron, right? P electron and D, PD. So we can directly, if you know this trick, we can directly find the value, right? Find the spectroscopic term. Okay, so SD means this one. Next is SF. SF. So this is going to be 1F 3F. Simple thing. SS means SP, P means P, SD. This term will check. Okay, SD, DD, SF, FF. Right? This one. Now SP, SS, SP, SP, SD, SF. Right? Now PP for PP. If there are PP electrons, okay. If there are PP electrons, in that case, this is going to be 1S PD, 1 SPD. Okay, this is 1P. This means 1S 1P 1D. Okay, and 3 SP SPD. Okay, SPD 3. So this is 1S 3P 3D, 3S 3P 3D. Now PD means 1 SPD, now PDF, okay, and 3 PD. Now PF is 1 SPD PDF, now DFG, and 3 DF 3DFG. Okay, now DD means this one 1 SPDFG and 3 SPDFG, and now DF is going to be this one 1SP one S, then P, D, F, G, H, okay, and 3 P, D, F, G, H. Last is FF, okay. For FF, it's going to be long one. This is 1 S, P, D, F, G, H, I, okay, and this 3 S, P, D, F, G, H, I. This is the trick, guys. You need to note down. So now we'll solve it. One question. Okay. Question is 3D1, 4D1. Okay. For this, you need to do for LS coupling. We need to find a spectroscopic term. Okay. So here L1 value is for D2 and L2 value is also 2D, right? And S1 value is, these are non-equivalent, okay, not in the same orbital. S is half and S2 equal to half. Okay, so we'll find this mod S is S1 plus S2 mod 2 S1 minus S2, and this we have already found, right? This is simple one, 0 and 1. Okay, and L value will find now. L value is L1 plus L2. I'm writing directly now. Okay, L1 minus L2. We have practiced a lot. So this one, 2 to the 4, 2 0, right? So 0, 1, 2, 3, and 4. Okay, L, right? Now for S equal to 0, for S equal to 0, value of L, L equal to 0, L equal to 1, L equal to 2, L equal to 3, and L equal to 4. So these values are there. So coupling S with this. First 0 with all this and then 1 with all this, right? L values, all L values. So from here, J values are, this is simple one. J value is going to be 0, J value is going to be 1, 0 plus 1, 1, J value is going to be 0 plus 2, 2, J value is going to be 3, and J value is going to be 4. Okay, 0 plus 4 is 4. Now we'll find the spectroscopic term, and that term is going to be simple. L equal to 0, multiplicity will find. Multiplicity 2s plus 1, S is 0, 2 into 0 plus 1. This is 1s 0. Second one is 1p1, 1d2, 1f3. These are spectroscopic terms. Okay, simple one. And this is 1g4. Okay, next is for s equal to 1, L value, L equal to 0, L equal to 1, L equal to 2, L equal to 3, and L equal to 4. Okay, so we'll find value of J value is going to be 1, 1. This is 1. Okay, and for this J value, I'm writing directly. So 1, 1, 2, 1, 1 is 0, 1, 2. From here, J value is going to be 1, 1, 3, 1, 1, 2, 3. And J value is going to be 3 and 1, means 3 plus 1, 4, 3 minus 1, 2, means 2, 3, 4. Plus, and J value is going to be 4 plus 1, 5, 4 minus 1, 3, means 3, 4, 5. Okay, now the spectroscopic terms are going to be L equal to 0 means S, multiplicity will find 2S plus 1, that is 2 into S1 plus 1, that value is going to be 2, 2 to the 4, 3, that is 3. Okay, 2 into 1 plus This value is going to be 3 S0. This value is going to be P0, 1, 2. This value is going to be 3 DL equal to D 1, 2, 3. This value is going to be 3 L equal to 3 means F 3F 2, 3, 4, and this value is going to be L equal to 4 means G 3G 3, 4, 5. Okay, these are the spectroscopic term, and this is how we do. Okay, for non-equivalent electron. Next. Okay, guys, just give me 1 second. Okay, 1 minute. I just got to work. Okay, guys. Next is okay. Now for ground state equivalent electron. Okay, so now we'll find the LS coupling for equivalent electron. Okay, so there is some different rule. Very easy. This one. Okay, equivalent electron. Equivalent electrons. So this. Okay, so equivalent. So which are in same orbital. Okay, so here very important thing you need to note down. Okay, this is easier than this non-equivalent electron. Okay, so we'll couple even with even combination. Okay, and second odd with odd odd combination. Okay, even combination and odd combination. Even combination and odd combination. Okay, so I will explain it by example. Okay, so I'm solving one example. So we have 2p2. So these two electrons are in the same orbital p, right? So that's why these electrons are called equivalent electron. Okay, so now we are doing LS coupling. Okay, so for this S1 value is half, S2 value is half. Okay, L value is 1, L1 value is 1, L2 value is 1, right? Because these are p orbital electrons. So now S value is going to be, so this is I'm writing directly, mod of half plus half to half, mod of half minus half, right? So value of S is going to be 0, 1. Okay, and L values are going to be 1 plus 1 to 1 minus 1, because L1 L2 are 1, right? 1 minus 1, 1 minus 1. So values are going to be 0, 1, 2. These are L values, right? Now we'll use this rule for equivalent electrons, even with even, odd with odd. Okay, so for S equal to 0, S is 0 is even, right? So we'll take L value or even values of L only. So even with even, and For s equal to 1, s is odd value, right? So we'll take odd values of l, right? So even for s equal to 0, even values only 2, right? Even values are 2, this 0 and l equal to 0 and l equal to 2. Only these two values will take and will couple. Okay, even with even, s is even, l should be even. S is odd, l should be odd. Okay, this combination we do in uh, equivalent electrons. So from here, J value is going to be 0. Here, J value is going to be 2. Okay, so spectroscopic term for this is going to be, so multiplicity 2s plus 1, right? 2 into 0 plus 1, that value is going to be 1. So 1 L value is 0 means S, and J value 1 S 0, and similarly spectroscopic term for this, uh, L equal to 2, 2 means D, 1 D 2. Okay, this one. Now second is odd with odd. For S equal to 0, sorry, S equal to 1, or L value will be 1. Only this will couple. Okay, not L equal to 2 and L equal to 0, because these are even values. So this point is very important. Even with even, odd with odd combination. Okay. Okay. So L equal to 1. So this value. So J value is going to be 1 plus 1, 2, and 1 minus 1, 0, means 1 comma 0 comma 1 comma 2. Right. So then spectroscopic term is going to be multiplicity 2s plus 1, that is 2 into 1 plus 1, and that value is going to be 2 plus 1, 3. So spectroscopic term is going to be 3. L equal to 1 means P. J values are 0 comma 1 comma 2. So this is the spectroscopic term. Okay. Next question I'm going to solve. So that question is, this is for 3D2. For 3D2, S1 value, these are equivalent electron, right? S1 equal to half, S2 equal to half. Okay. And L1 equal to 2, L2 equal to 2. So I'll write directly now. S value is going to be 0 comma 1, and L values are going to be 2 to the 4, 2 to 4, and 0, means 0, 1, 2, 3, and 4. Now because these are equivalent electrons, so we'll use odd combination and even combination, right? So this value is going to be, then for S equal to 0, values of L are going to be 0, L equal to 2, and L equal to 4. Even, right? 0 is even. So then value of J is going to be, for this, 0, and for this value of J is 2, for this value of J is 4. Okay. So now we can find the value. Okay. So L equal to 0 means S multiplicity will find. This multiplicity is 2S plus 1, 2 into 0 plus 1, that value is 1. So this value is going to be 1S0, and this is 1, L is 2, means 1D2, and 1G4, 1G4. Okay, this one. Next, for S equal to 1, value of L equal to 1 and L equal to 3 will take odd with odd, right? So these values are going to be, this one. J value is going to be 2 and 1, means 0, 1, 2. Okay, so from here J values are going to be 1 and 1, 2 minus 2, 3 and 4, right? So spectroscopic term is going to be L equal to 1 and multiplicity 2 S plus 1, right? 2 into 1 plus 1, that is 3. So this is 3, L is P, L equal to 1, P, 3P, 0, comma 1, comma 2, and for this 3 L equal to 3 means F 2 comma 3 comma 4. Okay, so 2 comma 3 comma 4. Okay, okay. Next is next is ground state term. Okay, ground state term. How to find ground state term? Ground state term. Ground state terms. Okay, so if for example if we have P3, so for this we have to find ground state term P3. P3 ground state term we need to find. Okay, P3 means 3 electrons, right? So this one, 3 electrons means this, and this. These are 3 electrons. Okay, and we can write like plus 1 0 comma minus 1. Okay, so since here you need to understand that P3 means L value is 1, right? Of P means L equal to 1, and we'll find ML value. ML values are minus 1 comma 0 comma 1, right? We can write because it is this one. So here this is ML, right? And we'll find that L values are going to be sigma ml. Sigma ml means minus 1 plus 0 plus 1. This value is 0. L value is 0. Now we'll find S value. S value is sigma ms. Since we have S values are this one. S1, S2, S3 are, we have values S1, S2, S3 are half, right? S1 is half, S2 is half, and S3 is half, right? S3 is half. So from here, our MS values are going to be MS values. S is going to be sigma MS. Sigma MS means these values. These values are going to be 1 plus 2, 1 plus 2, 1 plus 2. So this is 3 by 2. Okay, 3 by 2. 3 by 2. Okay, so J value is going to be L plus S, right? And here J value we have this, L value we have 0, right? 0 plus 3 by 2. Okay, that is 3 by 2. Okay, so ground state term is going to be ground state term. Ground state term is going to be this one. J equal to 3 by 2 and L equal to 0. 0, right? L equal to 0. So 0 means S and multiplicity is that this one, S equal to 3 by that S equal to 3 by 4, right? 3 by 2. So 2S plus 1, that is 2 into 3 by 2 plus 1, that is 4. So ground state term is going to be 4s. Okay, important one. Similarly, next question, for P4 we have to find P4. Again we'll do the same, this one. P4, okay. P4 means this one and this one, right? And this is 1 plus 1, 0, minus 1. Okay. So again we will find L value. L equal to sigma ml, right? Sigma ml. And L values are L equal to, so we know, so this is going to be L values are 0 comma minus 1 comma 0 minus 1 comma 0 comma 1, right? So ml value, so this is going to be, there are two electrons, 2 into plus 1 plus 1 into 0 plus minus 1 into 1, right? So this value is going to be 2 plus 0 minus 1. So this value is 1. So L value is 1. Okay. And S value is sigma ms. Sigma ms means this value. So this is plus half plus half plus this is minus half. These are in opposite, right? So minus half plus half and plus half. This will cancel each other, so this is going to be 1. S value is 1. So and J value, so S, LSS, J, so J values are going to be, J value is going to be 1 plus 1, 2, 1 minus 1 mod, right? So this is 2 and 0, 0, 1, 2. This is the value of J, right? So it means the spectroscopic term is going to be, and multiplicity S value is 1. So multiplicity is going to be 2s plus 1, right? That is 2 into 1 plus 1, that is 3. So J value is going to be 3, L is 1, right? 3p 0 comma 1 comma 2. 3p 0 comma 1 comma 2. Okay. So there is a trick as well. Trick I'm going to tell you. So electronic configuration for S1, for S electron 1, the ground state term is going to be 2. You need to note down, guys, okay? 2s half, okay? For fully filled electrons, that is 2s2, p6, d10, and f14. For these ground state term is 1s0, guys. 1s0, okay? 1s0 for the full electrons, okay? Fully filled electrons. S2, P2, P6, because in p orbital there are 6 electrons, right? Maximum in D10 and F14, right? So ground state term is 1s0. These are trick, guys. You need to note down. And for P1, so this is P01 and P5. P1 and P5. This value is going to be 2p 1 by 2 and 3 by 2. 3 by 2. Okay. This if you know this, then you can easily get the ground state. Okay. P2, P4. For this, the term is 1s0, 1d2, and 3p 0, comma 1, comma 2. For P3, the values are 2P 1 by 2, comma 3 by 2, 2D 5 by 2, comma 3 by 2, 4S 3 by 2. Okay, and for D1 and D9, for this the ground state term is going to be 2D 3 by 2, comma 5 by 2. Okay, next is for D8, the ground state term is 1S0, 1D2, 1G4, 3P2, and 3F2, 4, 3. Okay, this one. This is the trick, guys. So you can note down. Okay, so if you know it, you can easily solve things. Next is okay. So there is a Ohm's law. Okay, which time is already over. Okay, so what I'll do is I'll solve it in next class. Okay, I'll explain Ohm's law in next class. Okay, so remaining portion I'm going to complete in next class. So guys, I just would request the students who haven't subscribed my channel yet, please subscribe my channel and watch my free live lectures, which are going to help you to crack the exams related to physical science. Okay, and also guys, please share my lecture details with your friends so that they will also be able to watch my free live lectures and will be benefited from it. Okay guys, thank you.